We're going to start out Unit 7 by looking at the Blue People Pedigree case study. So this is a real um, case study, and this is a real thing that happened in Kentucky, and I'll show you that in a second. So first, what are the goals of this? The goals is to be able to make and read pedigrees. So pedigrees, yes, there's a dog food named Pedigree, but that's because if you're looking at purebred dogs and purebred horses, you're actually looking at their pedigree, their family lineage to see like how good of a dog they are if you're trying to breed them for a certain thing. Um, so that's what we're doing. Is instead of looking at how to try to breed things, we're going to be looking at these pedigrees to look at diseases. All right, so imagine that somebody came with a deadly genetic disease that runs in their family. So imagine this person right here. So came to you. They know, or even this sister here. She doesn't know what she is. So this before you made the pedigree, but she knows her brother has this deadly disease and he actually died when he was young. Imagine if she got married and wanted to have a kid. Does she want to have a kid that's going to die when he is 5 years old from a genetic disease? Or does she want to adopt or do some other thing so she doesn't have a kid like that? So, what we do is she'll go to a genetic counselor, which could be your job one day, where you do a genetic test and you figure out what her genes are, what her husband's genes are, and you set up one of these pedigrees and tell her the percent chance of having a kid, and you counsel her. All right. So we look at genetic diseases. Today you're gonna do a less devastating one, but they're about blue people in Kentucky. So these people were actually blue, and you're gonna read about this family and go through Kentucky. So let's look at what you're gonna do. So I'm gonna go through the first part of it together before you make the pedigree. So there you can fill in the goals and the relevance to the real world. So here's a pedigree. And down here, it's going to ask you to do some things. And in most of these answers are all in the reading, so you don't necessarily have to watch this part. So label each tier as grandparents, parents, or children. All right, well, this one's pretty obvious. So this one is the grandparents. This one's the parents. And this one's the children. All right. Let's see. Label each person as male or female. All right, so males. Males are blockheads, right? They're stupid. Every girl knows that. So all the squares are males. So this is a male. And all the circles are females. Oops. All right. Circle male. Blockheads, males. All right. Label the people with the trait. All right. So people with the trait are the people who are colored in. So in this instance, there's only two males that have the trait. This one and this one. All right, these people do not. The ones who are not colored in do not have the trait. All right, they have the. So if you're talking about blue, these people would be blue. These people would not be blue. All right. And if we're talking about a genetic disease, these people would have the genetic disease. These people would not. So now what's the next one? Explain how males and females are represented in the pedigree. We already did that. Squares and circles. Explain what the lines on the pedigree tell us about the relationship between the people. All right, so the lines on here, if two people are connected like this, so these two are connected, that means they're married and had some children. If it drops down and they're connected like this is brother, this is the sister, and then these are both the kids of these parents up here. All right. Now these guys get married and they have these kids down here and they're all brothers and sisters. So the lines tell you who had what kids and who's brother and sister and who's married to each other. All right, now on to the harder part. On a pedigree, how do you know if a person has a trait or not? They're colored in. We already talked about that. Above the trait is recessive. Fill out the genotypes of the trait. All right, so now this is what you're going to have to be able to do is you're going to have to be able to fill in these genotypes. So we know the trait's recessive, so that means these people right here, the ones who are colored in, have to be little r, whatever letter you choose to make it. All right, so the two colored in people have to be little r because the trait is recessive. Now, in order for these two people to have a kid, well, all right, so now we know that all the other people are dominant, right? So we can give them all at least one big R and give everybody else one big R here. And actually, I'm going to erase all this other stuff first so we can see these letters a little bit better. All right, so little r, little r, little r, little r. Everybody else has to have at least one big R, but we don't know if they're homozygous or heterozygous, which actually we'll talk about what heterozygous means in a second. All right, so in order for these two parents up here, these two, to have a kid with little r, that means he passed down a little r and she had to pass down a little r, so she has to be heterozygous, big R, little r. And then since she's like that, she would actually be a carrier, so you can color half of her in. That means she's a carrier, it means she carries the little gene but doesn't have it. Since he has two little r's, he can only donate a little r to all of his kids. So all of his kids should be big R, little r. So they got the big R from the mom, little r from the dad. All right, so then we'll color all of them halfway in. All right, so now let's look up here. He got, this guy right here, the square, got two little r's from both of his parents. So that means both of the parents had to have be heterozygous. And this one, we know it's a big R, but we're going to put a question mark. We don't know what it is. But let's just assume that big R, you wouldn't color any of that in. That'd be completely straight. So anyone who has a carrier would be recessive, and we'll talk about more of that in a little bit. All right. So now what you're going to do is you're going to read this scenario, and it talks about the blue people of Kentucky. And you have to figure out who is blue and who is not, and you have to make a pedigree. So you're going to make one of these that we just did up here. All right, after you make the pedigree, so you can draw it right in here in this big box. Just make sure you draw your small. Label any names that were in bold in the article on your pedigree. And then figure out if blueness is dominant or recessive, and then knowing whether the trait is dominant or recessive, now write your prediction of the genotype to the family for next symbol, just like we did before. So obviously, if blueness is recessive, they're going to be little r, and then you have to figure out who's going to be heterozygous. So just use the same principles we did up here. Remember, if someone has to have a kid and neither of them had the trait, they both had to be heterozygous in order to have somebody with the trait. And color them halfway in the pedigree, just like I did. All right, so that's what you're going to do for this section.